Hello everyone, and welcome to an introduction to k-means clustering. In this lecture, we're going to discuss the k-means clustering algorithm, which will allow us to cluster unlabeled data in an unsupervised machine learning algorithm. If you want the full mathematics behind this algorithm, go ahead and read Chapter 10 of an Introduction to Statistical Learning. K-means clustering is an unsupervised learning algorithm, meaning it takes in unlabeled data. It's going to attempt to group similar clusters together in your data. So what does a typical clustering problem look like? Well, a few examples may be things like clustering similar documents together, clustering customers based off of their features, trying to perform market segmentation, or even trying to identify similar physical groups. The overall goal is to divide data into distinct groups such that observations within each group are similar. Here you can see a diagram of unlabeled training data and k-means clustering trying to attempt to cluster the data into 5 distinct colored clusters here. How does the algorithm actually work? Well, you first choose a number of clusters k, and we'll discuss how to choose k later on. Then you randomly assign each point in your data to a specific cluster. Then, until the clusters stop changing, you repeat the following steps. For each cluster, you're going to compute the cluster centroid by taking the mean vector of points in the cluster. Then, you assign each data point to the cluster for which the centroid is the closest. Let's go ahead and take a look at this data visualization, or this plotted out visualization of a k-means clustering algorithm. You first start off with just the observations. That's shown on the top left. Then in the top center we have step 1 of the algorithm. Each observation is randomly assigned to a cluster. In the top right of step 2a, the cluster centroids are then computed. These are shown as large colored disks. Initially, these centroids are almost completely overlapping because the initial cluster assignments were chosen at random. In the bottom left, in step 2b, each observation is assigned to the nearest centroid. In the bottom center, step 2a is once again performed, and you can see that we've led to new cluster centroids. And we basically keep repeating these steps until there's no new clusters, meaning data points aren't being reassigned to a new cluster centroid. At the bottom right, we have the results obtained after about 10 iterations. Let's discuss choosing a k-value. As we just saw, to perform k-means clustering, we have to decide how many clusters we expect in the data. The problem of selecting k isn't actually that simple. There's no easy answer for choosing a best k-value. However, one way to try to do it is using something known as the elbow method. First of all, you compute the sum of squared error, otherwise known as SSE, for some values of k, for example 2, 4, 6, 8, etc. The sum of squared errors is defined as the sum of the squared distance between each member of this cluster and its centroid. If you plot k against the SSE, you will see that the error decreases as k gets larger. This is because when the number of clusters increases, they should be smaller, so distortion is also smaller. The idea of the elbow method is to choose the k at which the SSE decreases abruptly. This produces an elbow effect in the graph, as you can see in this following picture. Here we can see an example of a plotted out elbow method. On the x horizontal axis, we have the k-value, which stands for the number of clusters you choose for the algorithm. On the y-axis, you have the within groups sum of squares. You want to try to choose a k where you won't get that much more information by increasing the number of clusters, meaning you're not going to significantly decrease the within groups sum of squared error by increasing the number of clusters. And that's why this is called the elbow method, is you can see an elbow occurring around the number, let's say 6 to 7 clusters. That means that's a good number to choose for your clusters. Again, there's no correct k-value, so you want to use your domain experience or domain knowledge in whatever field you're working with in order to try to choose a correct or reasonable k-value. Now that we've learned about the theory behind the k-means clustering algorithm, let's go ahead and move on to showing some examples with Python. We'll start by showing you how to use scikit-learn's own built-in data generation tools to create some clusters and then test the k-means algorithm with scikit-learn. Then, for your portfolio project, you'll work with a real-world data set and try to cluster universities into groups based off of their features, and then you'll see if you can distinguish between private and public schools. Thanks everyone, and I'll see you at the next lecture.